okay. Ah, you're on top of it. All right. Okay, my name's Nic Benders. What I'm going to talk about tonight is building hosting environments, specifically building the server component of hosting environments, because there's a lot to talk about. I've been doing system administration and software development for over a decade, and I've seen a colossal amount of mistakes. I've committed many of them myself. I've seen many others. What we're going to try and do tonight is allow you guys to avoid some of the ones that I've done. We're going to start off with what should be a simple checklist of what goes into a server. A server is not a desktop computer that you put in a rack mount case and you slap in a rack. There are big differences. You need to make sure it's durable, it needs to be maintainable, and it needs to be scalable. There's a lot of stuff in normal PC world that does not apply. So we're going to go through each of these in a little bit more depth, and the idea being to avoid kind of the major pitfalls. If you hit everything on this list when you're building a server, then you'll be in pretty good terrain. Now, I realize a lot of people now don't build servers. A lot of people use managed hosting, you use slice host, you use maybe cloud computing where it's all done via API. But most large projects, it eventually comes down to a server in a colo somewhere. And whether it's being run by your managed hosting guys or it's being run by you, somebody needs to tell them how to do it. I'm going to start with hardware RAID. You must have hardware RAID. Do not ever run a server on software RAID. And this is the most important lesson on this whole sheet. I've seen software RAID ruin so many systems. It runs excellently when the array is fine. When you lose a disk and it goes into degraded mode, the performance falls apart. You have trouble booting off degraded arrays, and you miss out on one of the biggest advantages of a hardware RAID system, which is a battery-backed cache. Looks like this thing's just going to die on me. Here's a switch I did from software RAID to hardware RAID earlier this year. It's hard to read the labels here. What you can see is a sharp drop-off in database activity. This is measured in wait time. This is a screen from the New Relic RPM agent. The response time goes from a high response time up over a second to almost unmeasurable response time, and the throughput goes up. And the quality of service goes up. The reason that this such a dramatic change is not because software RAID is slow. It's because it doesn't have a cache. Without a battery-backed cache, you're doing what's called write-through, where every write that goes to the disk has to go all the way down to the disk and be acknowledged before it goes back to the operating system. With a battery-backed cache, you do write-back. I write to the cache takes care of it. It says, you know, I've got it, and turns around. So you're dealing with the write speed of memory instead of the write speed of disk. So this, in the case, was switching of a MySQL server. But this is also true for anywhere where disks are used. So you need RAID for performance, and you need RAID for durability. You need hot swap disks. Hot swap disks mean that when you lose a disk, you don't have to shut down the server. The whole point of RAID is to allow us to survive these failures. Without hot swap, you're still stuck having to shut down the whole machine, replace the disk, put it back on. That could be hours of downtime. In a hot swap environment, you just walk in, pop that disk out, put another one in, you're good to go. So we got our RAID taken care of. The next thing on the list, kind of in order of priority, is going to be remote console. You must have a real remote console. If you don't have remote access, it means driving to the data center. Your servers will explode at 2 a.m. That is guaranteed. That is the time for servers. When they blow up, you don't want to be on the phone to the poor guy who drew the 2 a.m. shift at the data center. That guy is going to be difficult. He's going to be angry. You're going to be angry. And invariably, what's going to happen is you're going to have upgraded the operating system. You're going to have ruined something in the bootloader, or something happened in your disk config, and so you can't get in. You say, well, could you just tell me what's on the screen? So remote console tells you what's on the screen. You need something that runs when the OS is not running, because that's the time when you really need to be into the system. The next thing you're going to need is you're going to need redundant power supplies. Your power supply has moving parts, just like a disk. That means it breaks just like a disk. Power supplies also have a lot of heat involved, which means they break even faster than disks sometimes. I've seen machines go through power supplies every 12 months sometimes. Having redundant power supplies also gives you access to redundant power channels. So if you connect your power supply into 2 different channels or 2 different circuits, when somebody comes through the NOC and is looking at something and trips and they unplug your cable, your machine doesn't turn off because you're still running on the other side. When somebody plugs something that shouldn't be in and you blow a circuit, one circuit blows, everything fails over to the second circuit. So the second circuit can keep you running. That way you can avoid, right there is the top 3 outages in terms of duration. It's disks blowing up, forgetting something and making a reboot that doesn't work, and losing your power supply. So moving to performance, you need a real CPU. Desktop CPUs are just not meant for this type of usage. A desktop CPU means, I've got one pipeline that runs very fast, or if you're running a multi-core system, maybe we'll have 2 or even 4 pipelines. What you need is the ability to move processes in and out of the CPU very quickly. We're not running 4 processes on a server, you're running 80 or 100. So you need good level 2 cache, and you need a lot of memory bandwidth. Ruby in particular is a memory hog. Ruby allocates memory and deallocates memory like it's going out of style. You must be able to move memory through as quickly as possible. The guys at 37 Signals did some benchmark research comparing the older Xeon processors with the Nehalem memory servers. They found almost a 30% boost in just, by changing the memory architecture. The way these processors work, and this is the current generation of Xeon processors, instead of having a memory controller on your chipset, your memory controller is in the CPU. Each CPU has 3 memory channels of its own. On a standard 2-processor board, that means you have 6 memory channels. Each memory channel can hold up to 3 banks of DIMMs, but you don't want to. Every DIMM you put in a memory channel slows it down. So you want to have 1 DIMM per memory channel optimally, or you can have 2 DIMMs per memory channel and have pretty good performance. If you put 3 in, your performance suffers by almost half. So now we've got our RAID, we've got our drives, console power supply, and we've got the processor. So this is the main pieces of our hardware put together. All of these things cost money. I can't just go to Fry's and put this together. All of these things require custom integration. You want to make sure that you have a server which is not just the sum of its parts, but is something that you can accidentally drop halfway as you're mounting it into the rack, that the guy who you're paying to uninstall it is going to hit it with a hammer and it's going to be fine. You can get this stuff relatively cheap. This is the Dell configuration. HP also sells comparable units. I prefer the Dells. This Dell config has everything we talked about there. Costs you about $4,000. It's a lot more than a PC, but it's not all that much money. It's worth the difference. This, by the way, is what Basecamp runs on, is the R710s. So now that the server's in place, we're going to get an operating system. Operating system is going to be Linux. We're not going to debate that today. The Linux is a great server operating system. Almost everybody here uses it. It's got a lot of distros out there, a lot of different people doing distributions. There are, in my opinion, only 2 distributions that are suitable for server work. You should either be running Red Hat Enterprise Linux, or you should be running the Ubuntu server with the long-term support option. It's that long-term support that is the important feature. Everything else that people put in a distro is not important in comparison to the length of the support. You can see Enterprise Linux 5 came out in 2007, but we're going to be getting bug fixes on it until 2014. With the Ubuntu server long-term support, the most recent version released in 2008, we get bug fixes until 2013. This means that when you build a server, you put it together, you burn it in, you get the OS on, you put it in the rack, you should never have to upgrade it. You should be able to apply security fixes, apply bug fixes, but never have to do a whole OS upgrade until the next time you pull it out of the rack and probably are putting it on eBay. It should run its entire life cycle on a single OS install. Some other quick Linux tips threw in here. A lot of these are common sense. Only install what you need. Do not start with the full distribution. I've seen a lot of servers out in the data center that have X windows on them, or have all kinds of crazy software they've thrown in. Just start with the absolute minimum package set and use your package tool to install stuff as you go. In Red Hat or CentOS, that's going to be Yum. In Ubuntu, that's going to be apt-get. By doing that, you avoid introducing software that you don't need. Software you don't need is bugs you don't need, and it's security holes you don't need. Every piece of software you put on a system is something that you have to maintain. Use logical volume management, especially for the root partition. Logical volume management means that when you add more physical disks later, or you change the size of your physical disk space, you can just grow your volumes without having to stuff additional partitions on there. You don't end up with like space/1 and space/2 and stuff like that. You can just add it into the main partition. Use ext3. There's a lot of nice file systems out there, XFS, ZFS. None of them are ready for prime time as far as a Linux server environment goes. You need to stick with software that almost everybody else uses. That way, when you have a problem, you can know that if I search for it, everybody else has the same situation I do. If you're running an exotic file system, that's going to be a big source of difference in between you and the rest of the world. Use the no A time option, mounting. No A time means that we don't set a access time flag when you read a file. By default, the way that the POSIX file system standard is written, every time you read a file, you set the access time. That means that every time you read a file, you write to a disk. This populates our disk with writes, and it slowly poisons our cache. Use no A time to avoid that. Don't rely on name resolution. Use etc host for all servers you need. If you have a database server, or if you have an NFS server, it should be in your etc hosts. You don't want to run into a situation where your DNS infrastructure is unavailable and suddenly you can't find your database. Use IP tables to put a final level of firewall in there. Your external firewall on the edge of your network is great, but maybe you don't control that, and maybe it's configured wrong. You should always have defense in depth. Make sure root's mail is being forwarded. This one's very easy, and many people forget it. A lot of software sends the error messages to root, and nobody listens because it's a server. So just go into etc aliases and tell root's mail to go somewhere where you're actually going to get it. And learn Chef. Opscode has a fantastic piece of software out there called Chef. If you manage more than one machine, you should really give it a look. So now our operating system's taken care of, the hardware's taken care of, we can actually get around to deploying the Rails app. For deploying a Rails app in a production environment, it's Apache and Passenger. That is the best configuration out there today. There's a lot of different ways to do a Rails app, but I think you're going to be happiest if you're starting a deployment fresh with Apache and Passenger. This is what my Apache virtual host config looks like. It's very straightforward. We have standard Apache document root stuff up there. We set the permissions on the directory, and then we get fancy with mod deflate to make sure that our text-based files go compressed over the wire. This is a nice savings for you in paying for bandwidth, and it gives a little bit of a pickup to your users who have limited throughput. So it's very simple. There's no mention of the Rails app in here. Passenger will detect that for you automatically. We configure Passenger, another config file in Apache. Again, very straightforward. A couple of lines at the top, load the module. Then we set a few options that aren't the defaults. We're turning on the global queue. The global queue means that incoming requests, instead of going to the next worker, go to the next available worker. This is an important distinction in the Rails world where often you're going to have some actions that will run 10 or 20 or 30 times longer than other actions. So this makes sure that the long-running action doesn't jam up your entire server. Set the max pool size. This is something that everybody has to tune on their own. Each app has a different memory footprint. Every server has a different amount of memory. So you want to be turning up your max pool size until you reach about as many as you can comfortably run without depleting your page cache completely or starting to swap. passenger pool idle time is 0. That disables idle timeouts. This is something similar in Apache. The original behavior here is passenger spawns worker processes. If a worker process doesn't receive any requests in, let's say, 5 minutes, it's despawned. This is great if you have a lot of shared applications on a server because you can trade the memory in the ones that aren't used for ones that are used. In a production environment, that should not be the case. You should want to have all of your processes running ready for work at all time. So we want to turn off the idle timeout. The flip side is then we're vulnerable to long-term leaks. So we turn on a max requests. We say after 1,000 requests, just kill off this process. Then we're using a custom Ruby. We're not going to use the system Ruby, particularly if you use Red Hat Enterprise Linux. You'll notice that the system Ruby is like 1.8.5 or something terrible. We're going to use Ruby Enterprise Edition, but we're going to call it with a wrapper script. Ruby Enterprise Edition is another piece of software from the guys who do Passenger. If you're not familiar with it, it gives you copy on write, garbage collection, and some other performance enhancing patches. One of those is tunable garbage collection. Everybody knows garbage collection in Ruby is not good. One of the things that's not good about it is it was designed for short-running scripts. So the defaults in 1.8 don't make any sense for long-running apps. So what we can do here is we can change those defaults by setting some environment variables. These particular settings come from Evan Weaver. They're great. I saw in my production environment 5 to 10% CPU reduction just changing these variables. There's nothing else to it. It's free CPU. What they do is they make the Ruby VM run garbage collection less often and more effectively. So what we do is our wrapper script sets the environment variables and just calls our Ruby Enterprise Edition binary. So moving quickly, we've got our server nailed down, we've got our operating system, we've got our Rails apps deployed, and a lot of people stop here. And it's very important that you don't. These last 3 items are just as important as the rest, although they're much less popular to do. Working backups. Working backups mean tested backups. If you have not tested your backup with a restore, you do not have a backup system. You just have an expensive tape hobby. If the most recent backup that you tested is going to be the most recent backup that actually works. If you can't live in a world where you had to restore from further than a week ago, you need to test backups every week. Backup systems break all the time, there's all kinds of problems, and you just absolutely, it's not working unless it's tested. Gigabit Ethernet. Oops. What? Stupid thing. Gigabit Ethernet. You need gigabit. A lot of people ask about this one because obviously your upstream connection is not gigabit for anybody, I think, sitting in this room. So you say, why do I need a gigabit in my network? The reason is you're trying to reduce the latency inside of your application. If you have one server talking to another, whether it's an NFS server or if it's a database server, whatever it is, it's going to take some amount of time to move those bits from one machine to the other. If you have gigabit, it's going to take less time. So get a gigabit switch in place. They're not that expensive. It's been a major technology now for almost a decade, and I think it's everywhere it's out there for 5 years, so there's no excuse to not have gigabit. You can get a very nice switch for about $4,000. That's, in my opinion, it's the nicest switch on the market still, 5 years. It's very fast backplane. It stacks to form a single switch. This is great if you're building a big wiring closet. We're probably not, so we can get a cheap switch. This Linksys switch that Cisco has bought will cost you $100 big. It gives you 8 ports of gigabit, and unlike kind of an at-home unit, it actually has remote management and it has flow control. If you don't have flow control, what happens in your gigabit network is where the gigabit meets the 100 meg, you have a lot of packets going upstream and they can't go any further. So without flow control, they just have to be dropped. And you're going to see a very high rate of packet drops if you don't have a flow control mechanism in place. So you need flow control on the gigabit network. And the last item is monitoring. We always talk about, tests in our code. We say, the code doesn't work unless there's tests that prove it works. It's the same for a production environment. Your environment doesn't work unless you prove that it does. So what you need is you need monitoring. You need two types of monitoring in a production system. You need alerting and you need performance monitoring. The alerting will tell you when your system is down. That's what's going to page you at 2 in the morning to let you know that you need to get on your remote console. So you need something that's relatively robust or relatively simple. Your performance monitoring is going to show you back over the last month. You say, well, when I put in place the garbage collection tuning, did that make things better? Did that make things worse? When we ran a big sale and our traffic doubled, did our load double? Or were we able to scale better? For alerting, Nagios has always been kind of the standard issue there. It's a bit of a bear to configure, but you can test for absolutely anything. You can alert on the weather if you needed to. There's a plugin for that. Pingdom, relatively cheap, relatively effective. It costs about $10 a month. We'll get you 5 monitors. It can check your site just for standard HTTP response, or you can do custom queries.
They also just added iPhone push notifications for free, which is pretty awesome. You don't even need a paid account for that.
That is pretty awesome. So I encourage you to look at that. It's the advantage of that over Nagios, other than the configuration, is that it's not on your network. So if they can't reach you, it's not because something happened upstream and you can still communicate on your network. They're telling you the outside world can't get in. For performance monitoring, Cacti is kind of the descendant of RRD tool. It means it's great for monitoring network traffic. It's great for SNMP stuff. It breaks down very quickly in large environments. And it really is meant for networking, guys. New Relic's RPM product, I already plugged earlier. I'll plug it again. That's fantastic. Everybody who has a Rails app live should at least be trying the free version of that. It's really a tremendous tool for answering the types of questions like, did this make my site better? Did this make my site worse? And questions of, what is the slowest part of this site? And that's our checklist. We've got to make sure that we have a server that's not going to break when we don't want it to, and that can be fixed rapidly. We have a Linux distribution that is going to be standardized, is going to be well supported. We have a Rails deployment technique that is fast and is easy. And we know that we have to test our backups, get some gigabit in there, and monitor it. And everything I've mentioned, I put up on the website if you need links. Just everything should be there. Also, the slides. Anything else that comes off the top of my head and I realize I misspoke, I'll put a correction there. And now, questions?
I've heard that Nginx is a better alternative than I've heard that Nginx is a better alternative than Apache in terms of being more lightweight and better performance.
Nginx. So the question about Nginx. Nginx is more lightweight than Apache. It's also less stable, less well supported. But the real problem is that it solves an issue that we don't have. Nginx solves the problem where you're spending too many resources in your Apache process. The idea of Nginx is that it's a lightweight proxy. It'll handle serving static content very, very quickly, more quickly than Apache. And it will handle a quick handoff faster than Apache's proxy balancer. But if we use Passenger as our Rails deployment technique, then we're actually serving up the content through an Apache module. So we'd have to use the slightly more beta Nginx Passenger to do it there. And really, the only thing we've saved is the amount of time in terms of CPU cycles necessary to serve static content. I would say that if you have a problem that you are serving so much static content it's slowing your site down, your static content should not be in your environment at all. Your static content should be being served out of Amazon with S3 and CloudFront.
And no, there was no mention of Capistrano, so.
There's only so many minutes in the day. I
Okay.
use Capistrano to deploy to. I know that there's been a lot of talk back and forth because the project is, it's not abandonware, I guess it's doneware. It's just, they just wrapped a bow around it. But certainly, I recommend that you use Capistrano, but there's a lot of other options out there too.
Okay, I'm kind of a newbie, so what do you use Capistrano to do?
Capistrano takes, it makes the bridge between the source code, which is on your machine, and getting it live on the server. So what it does is it provides a set of scripts that handle SSHing to the remote server, pulling down your SVN or Git source, putting them in place in the web directory, and then restarting the web server.
Thank you.
I had a question about security. Now you said, using the latest, or using a supported operating system is a great thing, and using, apt or yum, whatever is standard, and IP tables. Are there any good resources for the IP table stuff? Because that stuff can get really complicated.
It can get really complicated. If you're just using it as kind of a final line of defense, then I recommend staying very simple and just using it to open and close ports. I know on the Red Hat they have a firewall config tool, and then I know in Debian they have a different one. I don't know about the Ubuntu tool for doing that, but I would recommend, for a server that is not directly internet facing, that you can get 95% of the way there just by saying close all the ports and open up HTTP, open up SSH from this range, and open up I guess name service bidirectionally. If you need fancier stuff, like you're going to do NAT using IP tables and things like that, there are a lot of resources out there, but it is a little bit more complex. And similarly, you can do rate limiting for SSH connections if you have a box that needs to receive SSH from the world, but you don't want to have people dictionary attacking.
Gotcha. And the other question was, there's software out there to blacklist certain IPs if they're pinging your box too much, or if there's DOS attacks or anything like that.
I recommend against it. I've used some of that stuff in the past where you set up automatic defenses. You say, well, if we're getting port scanned, then we need to block down this list. It's more of a headache than it's worth. For the most part, you need to just accept your port scans and keep your ports tight and figure that everybody knows everything there is to know about you. If you get into a situation where you're dealing with a denial of service attack, then you do need a lot of fancier tools, and what you really need is work done at the upstream firewall, at the router.
Gotcha. Okay, thank you.
You mentioned that you don't like software RAID. What do you do in the event of a hardware RAID card failure? How do you protect against that? Isn't that a single point of failure if you do hardware RAID?
RAID controller failure is absolutely a single point of failure. So is motherboard failure. A couple other pieces of the system are very difficult to defend against. If you absolutely need a machine to be up all the time and as a single machine, then what you really need to do is deal with network attached storage or a SAN, where you can have a SAN device is going to have multiple RAID controllers within it, and then you'll have multiple pathways back to your server. As far as inside of a single server, you just have to keep the server from getting too hot, and always figure that you may have to overnight parts.
So the idea that you can take the disks out of a software RAID, put them into another system running the same version of Linux and have it come up, you don't see that as a worthwhile advantage?
No, because if hardware RAID, you can do the same thing as long as you have more than one machine that has that RAID card. So almost all hardware RAID cards are based on the LSI Mega RAID 1078. The Dell cards are, the HP cards are. Everybody is basically the same card in there. So something that I've done in practice is had a machine that had, in this case, it had a motherboard failure, but we just popped the disks out and we slapped them into a running machine next to it, and then we just added the RAID array on. And the Mega RAID BIOS stores RAID identifiers onto the disks similarly to the way software RAID does. So it recognizes when you put in new disks that they're part of an existing set.
My other question was, you mentioned alerting and performance monitoring, but you didn't mention either like Monitor God that do sort of an automated process restart or basically try and fix the problem until you can get to it.
No, it's a very good point. For production use, I do recommend that, yeah, you have Monitor God watching some of your stuff. Passenger obviously takes care of itself for the most part, but if you're running background RB tasks or you're running workling, whatever, something that requires background processes, you will be much happier if you have it running under Monit or God, because it can just crash a few times and email you about it instead of you having to find out from your end users. The other thing I forgot to mention was log files. Your log files will fill up, they will crash your system, it is guaranteed. If you do not have a way to rotate your log files, no one will think about it until it fills up the whole disk and everything blows up. So it should have been on the list. Pay attention to your log files. Have a system in place that does not require human intervention.
If one were to use a virtual server like a slice host or an EC2, do we just cut off the list, throw away the hardware part, and keep going?
Basically, yes. I stand by the deployment. If you are in a managed hosting facility, you have less of an emphasis on backups because they should theoretically be doing some of those for you. I still recommend keeping your own copies for catastrophic failure, but you don't need to be on top of it in the same way. But almost everything there, yeah, I think outside of the hardware would still apply to managed hosting, especially where you do administration yourself. As far as running your own system, virtualization is something I wanted to say. I recommend against it. I've done the full swing where I moved everything to virtualized, and now I'm going everything back. Virtualization gives you a lot of flexibility, but it really does eat a fair amount of your performance.
That was actually one of my questions, virtualization. But the other thing I was wondering about was the Linux distro. You're saying to always do long-term support. Do you typically build everything from source then, or are you still using apt or aptitude or?
I prefer to not build anything from source. I would like to. Obviously there are some things that you end up having to build. Ruby Enterprise Edition comes with a very nice installer. It builds itself. Things like that. Or if you need a version of Git that's not from 1,000 years ago, things like that. But your goal should be to have a standardized system. So you should be getting as much as possible from the vendor, and anything you can't get, you should make in your own packages to use repeatably on your systems to eliminate differences between servers. The advantage of the long-term support is that we don't have to go through this iteration a lot. Like Fedora does every 6 months, or doing every year. You don't want to have to upgrade your fundamental packages. You want a situation like you get in Red Hat Enterprise Linux, where if you get a bug fix or security fix, what they've done is they've backported that fix back to the version of OpenSSL that you have from 5 years ago, not asking you to upgrade to OpenSSL 1.0 and blowing everything up.
Yeah, and I agree. I like to use everything from the vendor as much as possible, but especially like in a year right now where Ubuntu long-term supports a few years ago, and you're wanting a lot of the latest stuff. It almost seems like I kind of take the approach that it seems like it's going to be a lot sooner that I'm going to be rebuilding the server than I mean.
It depends on the environment. Some are on your purpose. Generally, I find that you can cherry pick a couple of packages from upstream and rebuild them for your old distribution, and that what you're going to find is you're going to launch a product on this server, and then you're not going to want to touch it.
Yeah, I guess it depends on the project, definitely. So, all right.
You mentioned performance monitoring, and I don't remember, you said it was, what was the one that you mentioned? The first?
Well, I mentioned Cacti, which is
Cacti.
open source, and then the New Relic RPM, which is software as a service.
I'm curious if you've had any experience with Munin and used it?
I've not used it. I've looked at it. I misspent my youth and learned Cacti very well, and I can write templates and things like that. And so I'd never kind of branched off into some of the more modern options. There are, Munin's out there. There's a few other pieces of software out there that are designed to be less brittle than Cacti, which is really its major problem. And then if you do big network monitoring, of course, OpenNMS is an excellent piece of software if you happen to have that problem.
You mentioned both NFS and kind of SAN and passing. I'm wondering can you elaborate on how far NFS goes and when you would switch to SAN or something like that?
NFS goes very, very far. If I were designing a network, there would be almost nothing that you could do to me that would cause me to go to a SAN. I ran a Oracle server over NFS with clustered Oracle doing a lot of throughput. And if you have a well-built gigabit network and you're using quality back-end equipment, like you've got real NetApp filers back there, and you've got a good NFS client, in this case I was using Solaris, which has an excellent NFS client, then you can really get far more bang for your buck out of NFS because of the lower administrative overhead. If you have buckets of money, I would recommend using NFS, for any type of app server deployment, really, just to centralize the disks. The places where SANs stand out are if you have a lot of small writes, or if you need some type of very sharp cutoff in terms of failover. So the problem, NFS tends to kind of linger around on the locking end. The advantage is you can write to it from multiple places simultaneously. This is also the disadvantage. A SAN enforces your access. It gives you a more atomic control. But for instance, you would have to use SAN for MySQL because MySQL can't handle NFS locking semantics. But you do not have to use SAN for Oracle because Oracle can. Any other questions?
So as I said in my presentation, I've been messing a little with JRuby. Do you have any thoughts on using JRuby versus Ruby?
I've deployed a couple of JRuby projects. JRuby has some desirable performance characteristics, but it has two undesirable characteristics. The big one is its non-standard nature. Most things you do in Matz's Ruby are going to work in JRuby, but not everything. And some things are going to have kind of unpredictably large effect on your overall performance. That's the biggest problem by far with JRuby. The other performance characteristic is it's even more memory hungry than standard Ruby at small scales. At large scales, if you can get a good throughput in there, that problem diminishes. But I have not seen, in practical case, JRuby be competitive with standard C Ruby in production environment. Although I always keep hoping that it would, because Glassfish is a very nice deployment system. But it turns out that Passenger is where we're going to be for a while. All right, well, then that's it. Thank you.